Okay. So for these, all we're doing is multiplying. So you multiply coefficients, you add exponents. So in this case, I put 1 here. Oh, it'd be nice if I press draw. I put 1 here for my exponent on the x, and this would be 4 x. You would add the 4 plus 1 to get x to the 5th power. And then you'd have y to the 3rd. Any questions on that one? No. And then over here, I have a negative exponent, but I'm first just going to go ahead and I only have 2, right? Y is the only y. What is a negative 2 plus 3? No, negative 2. It's 1. So this would just be like this. You can do that if you want to. If you had 2y(x to the 3rd up here and then x to the 2nd down here, but you would still have to subtract those exponents and you would still get it like this. But when it's all together in one row like this, you can just add them to. You don't have to do that, but you should be able to get the same answer either way. Are we good now, Rosa? Okay. You could have made it more difficult and then gone around and still get the same answer. Oh, okay. So over here we have x to the negative 4th in the numerator. What happens with this negative exponent? What do I do with it? I have to bring it down and I'm going to make it positive down here, right? What about the y's? What happens with the y's because they're exactly the same? They cancel out. Now there's nothing on top, so I do have to keep a numerator. So I'm going to put a 1 up here. I'm going to have a 4. What's the exponent? We have x to the 3rd power times x to the 4th power. You add those exponents, so I get x to the 7th power. Very nice. Okay, over here, what's 4 divided by 2? 2. And I have an m to the 1st, m to the 3rd. When I subtract, because it's division, I have 2, but is the leftover going to be on the top or on the bottom? On the bottom, because you had more on bottom than you did on top. Because it would be like saying I have m, and then m times m times m. These would cancel, and I would have just 2 of them left on the bottom, right? That makes sense? Now this is a negative 2 on top, so what do? I need to move it to the bottom to make it positive. So now that's n to the 2nd power times n to the 1st power. 2 plus 1 is 3. And this should be the answer. How did we do on number 4? Are we still confused on those? Are we making any progress? Do I need to try explain it again? You're gonna okay. This one's the product rule. So I have negative 4, and these would have exponents of 1. So it'd be 2 to the negative 4 power, x to the negative 4 power. They're both negative exponents, so that means I have to change this into a fraction. What is 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16, and then this would be x to the 4th. Okay, over here, I have the power rule again. I'm going to put an exponent of 1 with that 3. So it'd be 3 to the 2nd. a to the 6th, b to the 8th, and 3 squared is actually 9. So it'd be 9a to the 6th, b to the 8th. We good? Okay. Over here, we are adding polynomials. We want to make sure we add the variables with the same exponents, right? And so I have to be careful. You also want to put your highest exponents first to put it in standard form. So here's my highest exponent, 2v to the 4th. Are there any other v to the 4th? No. So I'm not adding anything with it. I'm just putting it first. And I'm done. Now I need a v to the 3rd power. 4v to the 3rd, 3v to the 3rd. You add the coefficients, leave the variables alone. So plus 7v to the 3rd. Are there any v to the seconds? No. There's, yes? You said plus 7? Oh, because it's multiplication. We're adding. Okay. And so 4 plus 3 is 7v to the 3rd. There's no v to the seconds. There is a v to the 1st power, which is right here, but there's nothing to add to it, so I bring it straight down. And now I have -4 and -5, which is a -9. Remember, with adding, you don't change the variables or the exponents, and you add the coefficients of the variables that have the same exponent. So here, though, is subtraction. With subtraction, you have to change the signs. So I'm going to make this like a -1, and you're distributing a negative to each one of these. I'm also going to put this in order when I'm doing it, just because my brain works better when things are in order. What's a negative times a negative? Positive. And negative times positive is negative, and negative times negative is positive. I just reordered these so that by highest exponents, and I changed the signs. Yes, Rosa. Well, it's easier. I'm gonna put these in order too, and then I'm gonna add the ones that have the same exponents. Go ahead, Rosa. Sorry, you got interrupted. Either putting the 1 in front of the parentheses for the negative. Yeah, I just changed the signs. Are you good now? Okay. Yes. Over here? This one? Oh, I'm not done yet. Okay, now I'm going to order these just to make it a little easier, or I could put them right underneath each other. I may just do that. I'm going to stack them underneath by order. So this is a -4v to the 4th, -4v to the 4th. I'm just stacking them because they were all over the place. -3v squared. There wasn't a 7v to the 3rd, so I'm just going to stick it right in between there. Now I'm going to add. So we should have 3v to the 4th plus 7v to the 3rd minus 9v squared plus 1, right? I was just trying to organize them so it's easier for me to add because they were all mixed up in there. I'm just waiting because we good? Oh, okay, I can wait longer. That's fine. This final one here is the answer. It's just because they were all mixed up here and they were all out of order here. I placed this one in order when I distributed the negative, and then I just stacked these under the ones that were the same. But there were no v to the third, so I had to kind of fit it in between. Are you good, Dana? Okay. So this is what we learned yesterday, right? This is what we learned yesterday. And we have to do the distributive property to both. So 3n times 7n is 21n to the second power. And 3n times 3 is 9n. And a negative 2 times 7n is negative 14n. And negative 2 times positive 3, negative 6. Now I'm going to combine my like terms. So I get 21n to the second power minus 5n minus 6. Right? Is that what everybody got? Okay. So this one, I'm going to just change my color just because I have blue up on top there. 7r to the 3r, 7r times negative 5. So that would be 21r to the second minus 35r. And now I'm going to multiply negative 8 times 3r and negative 8 times negative 5. Negative 8 times 3r is negative 24r. And negative 8 times negative 5 is positive 40. And now I'm going to combine my like terms. They are both negative, so you add them together and keep it negative. So 21r to the second minus 59r plus 40. I'm going to do number 11, making a grid, and then I'll do number 12 without the grid, and you can choose which way you want to do these problems. Okay? So 3p and 3, 5p squared, 6p and 3. Oh, I hope I'll have enough room to fit everything. Okay. 3p times 5p to the second will be 15p to the second. No, to the third. Sorry. 3p times 6p is 18p to the second. 3p times 3 is 9p. 3 times 5p squared is 15p squared. 3 times 6p is 18p. And 3 times 3 is 9. Cross the diagonals, I'm going to add my like terms. So the like terms will be this 15p squared and this 18p. So the answers will be 15p to the third power plus 33p to the second power plus 27p plus 9. You don't have to do the grid, but I find it helpful. Do you find it helpful or no? Yeah, okay. So that's me with the grid. And then you can do it without the grid. You could do 2 times 2m squared, 2 times negative 8, and 2 times 3. So if I do that, it'd be 4m to the third power minus 16m to the second plus 6m. And now I'm going to do 8 times 2m squared, 8 times negative 8m, and 8 times 3. However, I want to try, I'm going to start lining it up under here. So 8 times 2m squared would be 16m to the second power. And 8 times a negative 8 would be negative 64m. And 8 times 3 would be 24. So it'd be 4m to the third. This is 0. That's a 0 pair. This would be negative, what, 58? Yeah, negative 58m. And then plus 24. So this is the grid way. This is not grid. It's totally up to you. Now, I only put this one down for those who like a challenge because I have some in here that are like, I like to be challenged. I have others that would be like, please do not give me any of those. The answer to number 13 is on the back. I can do it really quick, but for those who, this would be a bonus problem on the test. So if you don't get this one, don't get anxious about it. This is for those like Roe who want to challenge themselves. You finished it? Okay, so this is the power rule. So I have to multiply. So it's going to be x to the negative 3 power y to the 6 times 2x to the third y to the third over x to the negative 4. I'm just going, this is just 1, so I'm not even going to write it, times x to the 4, y to the 4th. So I like to simplify my numerator and denominator and then cancel out. X minus 3 plus x, or times x to the third, that cancels out to x to the 0. So that's just a 1. Y to the 6th, y to the third multiplied together would be y to the 9th. So the top would just be y to the 9th. Down below here, x to the negative 4 and x to the 4th, that's x to the 0, which cancels out to 1. And then I'm left with y to the 4th. And when I subtract those exponents, because it's division, your final answer should just be y to the 5th power. Hmm? Where? Did I do something wrong? Oh, I forgot the 2. Yep, so it should be 2 y to the 5th. Thank you. Yep, yep, 2y to the 5th. Okay, so remember, our do nows are reviews for our tests because I keep adding just a little bit as we go along. And by the time the end of the week comes for Thursday, these do nows look a lot like our tests. So it's always a, and I have extras, especially today because I accidentally printed it out twice. So if I were you and if I wanted to get an A on my test, I'd take a second one of these, do it at home when I'm not there, use your worksheet as this one as your answer key and just make sure you know how to do these, okay? Okay, so today we are going to start division of polynomials. I hope that was recording the whole time. Can't remember now. You put 5x over both of them because you're dividing. 15 divided by 5 is 3. 3 minus 1. Remember, you subtract those exponents with division. So that would be x to the second power. And the reason why you subtract is you have three x's. That's what x to the third power means. And down below here, you would have an x. Those cancel. You're left with just two of them. Over here, 25 divided by 5 is 5. 2 minus 1 is 1. You could choose not to put the 1 or put the 1. That doesn't matter. Does that make sense? Okay. Now, sometimes, what's this one? This is just another one without a remainder. This is another practice one. This is just more simplifying. So let's just do this one together. So 8x to the third divided by 4x plus 12x to the second divided by 4x. What's 8 divided by 4? 2. Right up here. So 3 minus 1 is 2. And over here, 12 divided by 4 is 3. And 2 minus 1 is just 1. Yeah, I'm just writing it underneath. Mm-hmm. Just in case you didn't understand making a fraction. Okay, sometimes though things don't end up nice and neat, that they don't divide equally. And then you are left with fractional answers. So if I am trying to divide this polynomial by 2x, I would put each term over 2x, and then I would simplify. What's 4 divided by 2? 2. And 3 minus 1 is 2. That one was good. Over here, what's 2 divided by 2? 1. And 2 minus 1 for the exponent would be just an x. So you could put 1x or you could just leave it as x. But over here, x divided by x, that's just 1, right? And I'm left with a fraction of 1 over 2. You have to write it as a fraction of 1 over 2. This one can't be reduced at all. 2 and 5 don't have any numbers in common. And there's no x up here to divide by. So you would just write it as 5 over 2x. And so you will have fractions with some of these answers. So here, I want you to go ahead and work on these. I'll walk around and help you. 1 and 2, they will be, you won't have any fractions. It divides equally. But number 3, you will have fractions in your answers. Very good. Did you get a second? The same thing Roe did. You forgot your one. So over here, when you divide by 3x, you should have had 3x to the third plus 2x. Because 9 divided by 3 is 3. X to the fourth minus the 1 gives us a 3. Over here, 6 divided by 3 is 2. X to the second minus x to the first is just x. Over here, 5x, 5x. A lot of people were putting x for the second one. You were not the only one, by the way. 10 divided by 5 is 2. We subtract those exponents. 5 minus 1 is 4. Anytime you have a variable or numbers or a combination, and it's the exact same thing in the numerator and the denominator, that's just 1. This should have been a minus 1. Some people were putting minus x, but x over x is just a 1. Yes.
So this is going to confuse my life because our equations before, they were positive, but we never put 1 when they cancel out. So because it's negative, we put a 1.
The negative had nothing to do with it. It's negative because this was negative right here because it had a minus sign. But anytime you have the exact same thing over each other, that's just equal to 1. That has never changed.
So I think what she's asking is, you know how in other equations, if it's the same, we just cancel it out. She thought that we would just cancel it out.
Well, we can't just cancel it out and just move on because there is nothing else, and it's not equal to 0, it's equal to 1. It actually has a value. Yes. Because we were adding and subtracting. Okay, now I'm getting where the confusion lies. I'm waiting until it's quiet because I'm not going to talk over people. I refuse. Okay, so when I'm adding and subtracting and they're opposites, the value is 0, right? A negative 5x plus 5x is 0. So when you have negative 5x and a positive 5x, the reason why I wouldn't write anything is because 0 is 0, meaning nothing. But that's different than division, because when you divide, we actually get an answer of 1. Oh, now thank you, Ro, because, I wouldn't have understood where they were confused without you showing me where that confusion lies. Are we good now? Okay, yay! But it's good for your brain. We're making it grow. And you're building pathways in your brain, and you're never too old, because I'm starting to read up and doing research about math pathways. And because I was curious to know if there was ever a time in your life then that you get too old to build those pathways. And you don't ever get too old. It just may take a little bit more time because our brains crystallize as we get older. But what you are actually doing when you say, my brain's hurting, you are building pathways to make math easier as you keep going. Yes, a lot of good roads. Good. For this one, we would take 4x squared and divide it all the way across. And of course, 4x squared over 4x squared is what? 1. This is going to be a 1. So 16 divided by 4 is 4. X to the third divided by x to the second. You would subtract those exponents. That's an x. This is 1 because it's division, not adding or subtracting. Plus, okay, this confused people because I had more exponents on the bottom than I did on top. When I subtract and there's more on the bottom, those leftovers have to be on the bottom. So this should be 3/4 x. Because 2 minus 1 is 1. You had more on the bottom, so leftovers go on the bottom. And this one can't be simplified at all. There's nothing we can do, so it's just left like this. You good? Okay. Just wait till you get to algebra 2 and you divide it by a binomial. Here we're just doing monomials. When you get to algebra 2, we actually divide by binomials. That's a lot of fun. Yeah. But you see how it builds. Yes. And that's why you want to build those pathways now so you can pass algebra 2. So, greatest common factor. If you took math foundations, you probably talked about greatest common factors. I didn't print, and I'm going to run and make a copy of the factor charts for you all. Darn it, I should have had that. I forgot to make those copies this morning. So, factors of 12. Okay, wow, let me back up. We're trying to find the greatest common factor of 12x squared and 18x. And I gave you the answer is 6x. Down here, I'm explaining why. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Those are all the whole number combinations that you can multiply to get 12. Everybody agree with that? Okay. For 18, all the whole number combinations for multiplication to get 18 are 1 and 18, 2 and 9, 3 and 6. What's the biggest number that these lists have in common? 6. So 6 is going to be the coefficient that they have in common. Now you look at the variables. You always take the smallest variable because it has to have it in common. So what's the smallest exponent on these variables? We have x to the second and x. Yes, you use the lowest exponent. So that's why the greatest common factor is 6x. Okay? Oh, I have a factor chart that does all the factors up to 100. I'm going to print that out for you. You're going to list the factors of each term. You use the lowest exponent that they both have in common. You find the common factors, and then you choose the greatest one. So, like here, I have 15x to the third and 25x squared. The numbers of 15, the factors are 1, 15, 3, and 5. 25, the factors are 1 and 25, and 5 and 5. What's the biggest number they both have in common? 5. What's the lowest exponent on here? X to the second power. So it's 5x to the second power is considered the greatest common factor. Okay, we're not multiplying. What we're trying to do is find the greatest common factor, the biggest term that divides equally into both of those terms. 15's factors are 1 and 15, 3 and 5. 25's factors are 1 and 25 and 5 and 5. The largest number they both have in common then is 5. But then you look at the variables. See how you have x to the third and x to the second? You have to choose the smallest exponent because that's what they would have in common. So that would be x to the second power. So while you guys are doing this one, I'm going to print off a factor chart for you to make your life easier. Let me go ahead and do that. Ooh, why is that doing that? Oh, thank you. I appreciate it. I the I don't know. Is the general working? It was causing issues. Yeah, I can send it to the admin because the other one was having. Well, I'm gonna. What? Uh, I'm gonna make enough for extras, so I'm gonna do 40. Yeah, that way it'll be for both classes, and then. Okay, so for number one, you should have had 2 is the greatest number that 12 and 10 have in common. And the least exponent would be x to the third power. Did everybody get 2x to the third? Okay, so over here, 10 and 20, it should be 10 is the greatest common factor for the coefficient. And then x to the second, and then y. Because remember, you choose the lowest exponent, so it'd be y and x to the second. Over here, 14 and 6 only have the number 2 in common. And I'm going to have an x. I will have no y, because this one does not have a y. So you do not put a y because they do not have a y in common. Remember, the key word is greatest common factor. So over here, it would be 4 and y and x. I decided to jazz up this PowerPoint. Do you like all the flower pictures? I don't know. I just decided to put flowers. So pay attention. This is new. I'll wait till it's quiet. For factoring out the greatest common factor, you will find the greatest common factor, and then you're going to divide by the greatest common factor and leave that answer in the parentheses. So, right here, if I'm asking you to factor 6x squared plus 9x, I would have to find the greatest common factor. Well, 6 and 9 have what number in common? 3. And the lowest exponent is x. How I get 2x plus 3 is I take that greatest common factor and I'm dividing. So you would divide by 3x, divide by 3x. And that's what goes into the parentheses. 6 divided by 3 is 2. X to the second power divided by x would give me x. Then for the next term, 9 divided by 3 is 3. And x divided by x is just 1. So 3 times 1. Yes.
We wouldn't subtract these variables. like because they're in.
Well, what's okay?
Sorry, not the variables. The
Exponents? Yeah, I did. What's 1 minus 1?
Well, I heard you say divide.
Yeah. Okay, so this then you put the greatest common factor in front, and then you put these answers in the parentheses. So this is your first factoring problem, with me at least. So over here, let's look at this one. 15 and 20. What's the largest number they both have in common? 5, right? And what's the lowest exponent? Y squared. This would be the GCF. And that's, we're factoring out the GCF. So now I'm going to divide each one of these by 5 squared. 5y squared, sorry. What's 15 divided by 5? What's y to the fourth divided by y to the second? 4 minus 2 is 2. So that'd be y to the second. Minus, what's 20 divided by 5? 4. Y to the second divided by y to the second is 1. So that cancels, and 1 times 4 is just 4. So that's why it's just 4 here. And this would be 15y to the fourth minus 20y to the second factored. So you kind of put together the dividing and greatest common factor. So I want you to do these. I want you to find the greatest common factor. That goes here in the front box or in the front space. And then you're going to divide by the greatest common factor, and that's what goes in these second spaces here. Okay? Yes. Okay. Yeah, over here should have had a plus. I apologize. That should have been a plus. Okay, for this one, when I'm dividing, 16 and 12 should have had a 4 is the greatest common factor. And then if I look at the x's, the smallest exponent would be x to the 3. Am I going to have a y? No, because this second term did not have a y. So now I divide both of these by 4x to the third power. 16 divided by 4 is 4. X to the third over x to the third is 1. 1 times 4 is 4, so that just cancels out. And then I'm left with y squared. 12 divided by 4 is 3. 4 minus 3 for those exponents for the division would be just x. Now, if you multiply this out, you should get the exact same answer you started with. 4 times 4 is 16. X to the third, y to the second. See how that's the first term? And if I multiplied 4x to the third times a minus 3x, I get minus 12x to the fourth. I know I did it right if I could multiply this out and I get back where I started from. So over here, what did you all have? What would be the greatest common factor of these two terms? And please put a plus here. It would be 1 would be the number. What would be the variable? Z to the third power, because this one had a 3, this one had a 4, right? So if I'm dividing both these by z to the third, I would have 5x z. And this would just be a 1, not 0. Because z to the third over z to the third is a 1. Okay, what did you get over here? 3x y. I'm going to divide these by 3, x, y. 9 divided by 3 is 3. And y over y cancels. And 3 minus 1 gives this to be squared. And this one would be just x to the second power squared. Yes. Got it? Okay. Now, there's a lot of problems on your sheet. I'm going to take off